So if today works, then we will have 2 reconstructions. One will be better because we used pose images, and one will be worse because we didn't.
We're testing this asset in particular because one huge problem with 3D reconstructions is understanding where each image is with respect to each other. That's called the alignment step. And traditionally at Gecko, we've used purely camera-based means to understand where assets are with respect to each other. And so if 2 photos look very similar to each other, it's very, very hard to build the final model. And this asset is very plain and doesn't have a whole lot of what we call features, doesn't have a lot of texture. And so we're testing a system that uses more than just images. Josh just extracted all the raw data and the post-process data.
So the drone captured these 2 panels quickly. We're going to process them with the poses of the images calculated, and we're going to process them without that information. So we can kind of apples to apples see the improvement that the poses make.
And then we're going to use that information in our reconstructions to try to build these accurate models that will allow us to do remote visual inspections. I'm gonna go start the reconstruction. We're going to the Threadripper machine, which is a very powerful CPU, so we can complete this reconstruction as fast as possible. All right, I am downloading the images right now. Once I have those, we're gonna do the reconstructions. So this is showing us exactly all the camera poses that we get from the drone, which are gonna help. This is the key factor that's gonna determine whether Will's model is better or my model is better with the poses. Are you ready?
Yes.
All right. So this is Leslie.
He's running there, and I'm running here. Well, you need posed images, which we've both achieved through different paths.
So he basically just has like a computational shortcut.
Well, because I have the pose, I can take the LiDAR point cloud that we had from that flight, and I can use that too. Even if alignment isn't necessarily a problem, you do have a huge problem getting geometry without LiDAR.
Yeah.
So the extension of our experiment that we're going to run right now is getting the co-localized LiDAR save us from a featureless space. The challenge of the featureless space is overcome by getting data from a different sensor. Cameras are really bad at getting featureless spaces. LiDARs, because they bounce off of anything, they're really great at it. I discovered another problem with this model, which if you look here, there's this mysterious plane of points jutting out from the wall. And that's actually the point cloud generated from the photos. And then you can compare that to the point cloud that is coming from the LiDAR. And you can see a clear misalignment between these 2 data points. And so what I've been working on today is extracting the data in such a way that it accounts for this misalignment. When the drone is on the ground, it's not perfectly level. And so when it takes off, it makes the assumption that whatever angle it's at is actually level with the ground. So as it flies up against gravity, it has to fly in what it thinks is an angle as it goes straight up. In the post-processing world, they have the luxury of being able to see in real time the IMU data, which is the same sensor that your phone understands which orientation it's in, to understand, oh, actually gravity is pointing this way, and that then allows everything to align in the proper vertical direction. So once I solve that, we should have a totally aligned pair of point clouds, creating a single mesh that will capture in detail this very beautiful Gecko logo we have in the corner of our screen here. I was able to use some very common tools just to get those 2 bits aligned much better, then take down the noise on the spatial data itself. And I was able to combine them in this application to render this huge model of the space. And I wasn't expecting to capture such a huge part of the space. Again, we were only trying to capture this one section of the tank here. But then when I actually rendered it, like you could see an incredible amount of detail. And this again all comes from the fact that we were able to very precisely align the camera data that we had with the spatial data that we had from LiDAR sensor that's bouncing the light off of all the objects. As excited as I am about this and as happy as I am with the results so far, I want to make this continue to get better, and I want Gecko to continue to develop its expertise in dissecting and understanding the health of the built world. I think it's an incredibly important problem for our company, for our country, and for the world, and I'm so grateful to be a part of it.